This is Unit 5, Lesson 6. I called it Part 1, Mole Ratios. The lesson is so big I broke it down into parts, and the objective is that students will be able to write proper mole ratios from a balanced chemical reaction, and our only vocabulary term for this part of the lesson is mole ratio. So before we talk about mole ratios, I just want to talk about the word ratio, which I'm sure you've heard before, and if I were to talk about let's say the ratio of guys to girls in a classroom, I might say that the ratio is 11 to 8 guys to girls. I think that's how you're used to seeing ratios with the colon there, but we're actually going to change it, and in blue here, we can also write this as 11 guys to 8 girls, and you would probably call this a fraction, but ratios can be written either this way or this way, and we in this class are going to use this one. We'll see in a little bit why that is more useful to us. So let's look at a common reaction here where hydrogen gas reacts with oxygen gas to form some water. And instead of talking about guys and girls like I did in the last example in my ratio, now we're going to talk about mole ratios. So what I'm really interested in here are the moles. So the first thing that you need to know is that the coefficient out front here, coefficient, which we've learned before, is the number of moles. Okay, so if I asked you how many moles of H2 there are, you would tell me 2. If I asked you how many moles of O2 you have, you would tell me 1. How many moles of H2O do you have? You would tell me 2. Okay, so the coefficients will tell you the number of moles. And if I want to write a mole ratio, I just read the equation and say how many moles of the substance I have. So I'm just choosing, let's do H2. I have 2 moles of H2 for every 1 mole of O2. Again, getting these numbers from the coefficients in the equation. So that's 1 mole ratio. It does not matter whether I put this on top or this on top. You can choose whatever one for right now. Let's do one more here to make sure that you understand. I could also say that for every 1 mole of O2, there are 2 moles of H2O produced. Okay, again, I could flip these and it would be correct as long as I write the correct number of moles and write them as a numerator and denominator. And that, my friends, is really as simple as it is in terms of how you write mole ratios. So we'll do one example problem here where you try now to write the mole ratios for this equation where we react iron and sulfur to form iron 2 sulfide. This is the reaction we did in class that smelt like rotten eggs because of that sulfur gas that we heated up. So what I want you to do now is see if you can write all the possible mole ratios for this equation. So you're going to pause me and do that, and then you can check your answers. So go ahead and pause me and try, please. Alright, I'm going to give you some answers. One possible mole ratio is for every 8 moles of Fe, there's 1 mole of S8. Another ratio could be for every 8 moles, oops, sorry, that was my phone. There are 8 moles of FeS. Those are 2 possible mole ratios, and I think there's one more. For every 1 mole of S8, there's 8 moles of FeS. So those are the 3 possible mole ratios. Again, I don't care if you flipped them and put one on the other one on top and the other one on bottom. As long as you have those, you are correct. All right, and that's it for this lesson.